topics, which is very important topic, which I'll be discussing now on set theory. Uh, okay, so we'll be just starting right now. Okay, now as when we understand what is set theory and all that, so okay, uh, set theory definition itself is a collection of objects. What do you mean by well-defined collection of objects? So it means that it is possible to decide whether a given object belongs to the given set or not. Okay, or any such subject which is object uh, in the set is called its member or element. Okay, a German mathematician uh, Cantor, okay, during 1845 and 1918 developed the theory of sets. So, uh, in a mathematical language, all the living or non-living things in the universe are known as objects. So, a well-defined collection of all distinct objects is known as a set. Okay. Generally, sets are denoted by capital letters, which is A, B, C, and so on. Okay, capital letters. And their elements are denoted by lowercase, which is small a, B, C, and so on, which is lowercase. So X, Y, Z, and so on. So if you consider A, capital A, being a non-empty set, okay, if I consider capital A, it is a non-empty set. If X is an element of A, then we write X belongs to A. Okay, X belongs to A, which is read as X is an element of A, or X belongs to A. Okay, if X is not an element of A, then we write as X not belongs to A, or is not an element of A. Okay, that means. Okay, now for example, if I have a set A, if I consider a set which is equal to 2, 4, 6, and 8. Okay, I have sets which is 2, 4, 6, and 8. So this is the notation of the set, okay, which is capital A, and the elements or the members of that set belongs to the members. Okay. Also, if you uh, look into this also, 2, 4, 6, and uh, 8. So we can write 2 belongs to A, 4 belongs to A, and 6 belongs to A, as well as 8 belongs to A. Now, if you consider 3, so 3 does not belongs to this set. Okay, uh, so it is not a member of the set. Okay, uh, now let me just talk about some of the collection of the set and the choices I will give and the solution also. So now if I consider the collection of all boys in your class and another choice if I have the collection of intelligent boys in your class, another choice if I have the collection of smart boys in your class, I have another choice which is the collection of all tall boys in your class. So if you consider the solution for this, uh, here the collection of all boys in your class is the following uh, collection, which is a set. Okay, and clearly you can see the other is specifying or it is not uh, well-defined collection. If you look into intelligent boys, smart boys, and tall boys, okay, they do not form a set. Okay, now the representation of a set, we have that. How do you represent a set? Uh, Usually, a set are represented in the two different ways. Those are a roster form, or which is also called as tabular form, set builder form, or rule method. Okay, so we have the set which can be represented as roster form. Okay, roster form, or it is also called as tabular form. Okay, this is one type of set representation. Also, we have set builder, okay, form, or you have rule method. So these are the two representations of the set. Okay. Now let us see what is uh, uh, one which is roster form and one which is tabular form. Okay. Let us try to understand. In this method, all the elements. Okay. If I have roster form, in this method, all the elements of a set are listed, separated by commas and put in within braces. Okay, within braces, within curly braces. Uh, so this is a roster method or a tabular method. So I'll give you one example. If I consider set A, okay, set of all prime numbers less than 11. Okay, if I consider a set which is a set of all prime numbers, but it is less than 11. So I can consider 2, okay, 3, 5, and okay. I hope you understood how we represent a roster form here or a tabular form. Okay, let us look in one more method which we have as set builder method or rule method. Okay, so in this method, instead of listing of all the elements of a set, we list the property or properties satisfied by the elements of the set, and we can write it as A is equal to X such that P of X. Okay, so it is read as A is a set of all elements X such that X has the property P of X. Okay, the symbol this stands that the symbol stands that such that, okay, such that. For example, if I consider a set, okay, I have the elements which are 1, 2, 3, 4, 5, 6, 7, 7, 8, 9, and 10. These are the elements 1 to 10. Okay, so this is written as x such that x belongs to n. Those are natural numbers, and x is less than or equal to 10. That's what it meant. So this method is known as rule method also, and or the property method also. Okay. And keep a note that the order of the element in a set has no importance. For example, uh, if I have uh, if I have A B C, if I have A B C, okay, and if I have C A B, are the same set. So the order of the element is a set and has no importance in that. Okay, since it is same elements are there in a set. Now, the repetition of elements in a set does not affect the set. For example, if I have A, B, C, okay, I have A, A, B, C, okay, are the same sets. Okay, the repetition of elements in a set does not affect the set. Okay, so keep a note of these 2 points which I mentioned. Now, further, let us consider few more examples here. Okay, few more examples here. If I if A is a set whose elements are obtained by adding 1 to each of the even numbers, then the set builder notation of A is, the choice is given here. If I have A which is x such that x is even, okay, let me repeat the question again. If A is a set whose elements are obtained by adding 1 to each of the even numbers, then the set builder notation of A is, okay, what will be the set builder notation of A? Okay, so is A is equal to A x such that x is an even number. I have another choice which is A is equal to x such that x is odd, x is odd, okay, x greater than 1. I have another choice here, okay, which is A is equal to x such that x is odd, x is odd, and x belongs to n. Okay, I have another choice here, okay, that is A is x such that x is an integer, x is an integer. Now, if you notice that these 4 choices I have, so the correct answer should be C. Let me explain you. So, when we add 1 to an even uh, integers, okay, so we obtain odd integers. So, x such that x is odd and x belongs to n, which is a natural number. Okay, did you understand this? Okay, if you have any queries, you can ask. Okay, I hope you understood this, right? Okay, let us try to understand another problem here. Okay. Now, if I consider again which of the following uh, is an empty set. Okay. Let me write down the choices which we have here. Okay. Now, A is x such that x is a real number, okay, and x square minus 1 is equal to 0. Okay, so that's the first choice we have, x such that x is a number, a real number, and x square plus 1 is equal to 0. I have another choice here. Let me write down another choice, x such that x is a real number and x square minus 9 is equal to 0. Okay, let me write down another choice we have, x such that x is a real number and x square is equal to x plus. Now, which of the following is an empty set? So, if you look at these four options, I would prefer B. X square plus 1 is equal to 0. Why? Now we observe that there is no real number x such that x square plus 1 is equal to 0. Okay, so x square being minus 1. The square root of this is uh, is a real number but cannot be negative. Okay, what does that mean? So this is square root of x is square root of minus 1. So it is an empty set. Okay, so we can define this is an empty set. Okay, so this would be the right choice here. Okay, let me take one more example. Okay, let me take one more example here. Now, before that, let me take one another concept here. So here we have looked into the representation of a roster form and a set builder form. Okay, and now we'll try to understand uh, what is a singleton set. Okay, a set which has only one element in it is called a singleton set. For example, if I have set A, okay, and the set of present uh, president of India. So the set of present president of India. Okay, so it is a singleton set, and this is one such example. I can write another. That is, if you consider two or zero or a null set. Okay, so these are singleton sets. Okay, Now let us uh, see one such example of a single tensor given to you. Now I have choices as a x such that mod of x less than 1 and x belongs to z. Okay, I have another choice b x such that mod of x is equal to 5 and x belongs to z. Okay, I have one more choice x such that x square is equal to 1 and x belongs to z. Okay, another choice I have x such that x square plus x plus 1 is equal to 0 and x belongs to R. Okay, I have these four choices here where z consists of all integers and R consists of all real numbers. What would be the best choice here? For this, I have A as a solution here. So let me explain you why I have chosen A as the solution. If mod of x is less than 1, this means that x lies between minus 1 and 1. Okay, and therefore x is equal to 0. Since x is the only integer between minus 1 and 1, this set therefore has only one element in it, which is x is equal to 0. So only one element exists. So this is the perfect single singleton set here. I hope you understood this. Okay. Let me continue some more uh, problems and concepts in the next session. Thank you for listening.